Production is simply the conversion of raw materials into finished goods. Our raw materials in this case are labor and capital. Labor and capital units are our raw materials. Now, for us to understand production theory very well, we will likewise be able to understand input choices, production technology, and cost constraints. So the factors of production that we're going to look at in this session of our lesson will be capital, which is denoted by letter K, and labor, which is denoted by the letter L. So production is a conversion of input into output through a production process. So our input materials are the labor, capital, and other materials. Specifically, will dominate mainly on capital and labor. Now the function of production in this case will be dealing with the letter Q. Q stands for the total output. Letter Q stands for the total output. So we'll look at production in terms of the short run, in terms of the long run, and in terms of the fixed input factor. So production, firstly, we'll need to understand the lines that join points that offer the same production are called isoquants. The lines that join points that offer the same production are called isoquants. These isoquants are convex about the origin. They give the origin the back. They are parallel to each other. Isoquant number 3 has higher output compared to isoquant 2, which is higher than isoquant 1. However, the optimal production will always be at point B. Point B is called the marginal rate of technical substitution. This point is a point where production is optimal. At point A, we are underutilizing the resources. At point C, it's unattainable. At point B, it's optimal. The reward for labor is called a wage. The reward for capital is called rent. And so the cost function is given by C is equal to rent for capital plus wages for labor. So the isoquants, which are the lines joining the points that offer the same production, are concave. They are parallel to each other. They are optimal at a point where the budget line is tangent with the isoquant itself. At a point where MPK over the rent is equal to MPL over the wages. So the point B is called the marginal rate of technical substitution. Marginal rate of technical substitution. Now I want you to familiarize yourselves with the terminologies that we in this course are going to use. What does TPL stand for? TPL stands for the total product of labor. Q is actually the total product. When we divide the total product of labor divided by L, we call that the average product of labor. We also have what we call the marginal product of labor, which is simply the additional unit per increase in 1 unit. So average product of labor is simply the total product divided by the labor unit. The marginal product of labor is simply the additional unit that we have produced due to an increase in an input use. So average product of labor is simply the output over the labor unit. So we've agreed that output is simply Q over the labor unit, which is L, and this Q is also the same as the total product. The marginal product of labor is simply the change in the total product over the change in the labor unit. So most of you are familiar with calculus, but sometimes you'll be given a production schedule. We have the number of laborers 0, 1, 2 up to 10. The total amount of capital K, which is constant, which is 10 throughout. And we have the total product or the total output Q, which is 0, 10, 30, 60 up to 100. So when we divide our total product Q divided by the labor unit, what we get is called the average product. So 10 divided by 1, this is called the average product of labor, which is 10. 30 divided by 2, this is 15. This is called the average product of labor. So 30 divided by 3 is 20. 80 divided by 4 is 20. And so on and so forth. 100 divided by 10 is 10. Now the marginal product of labor is simply the additional units that we are having for every extra unit of labor. So from 0 to 1, what additional units are we having? So we're looking at the total product here, the difference here. So 0 to 10, we're getting an additional incremental units of 10. Okay, we're looking at it from the total product. So from 0 to 10, we're having additional units of 10. From 10 to 30, how many units are we adding? 20. From 30 to 60, we're adding additional units of 30. From 60 to 80, we're having additional units of 20.
20.
So 80 to 95, 15. So now, as you can observe here, the marginal product is increasing until it reaches the maximum point here. Then it starts going down, and it goes into the negatives. So this is what we call the law of diminishing returns, that the total product will continue increasing until a certain point where it reaches the saturation point and starts going down. So this is how it looks like. So when we're increasing production and it reaches a certain point, it begins to decline. So the total product curve in A, output is produced at different level. Is that a question? So total product is produced at different units of labor, as you can see. The average and the marginal revenue products are identified in table B here. So this description of the 3 stages of production is important for you as a manager in managerial economics to explain the 3 stages of production. So there's stage 1, stage 2, and stage 3. So as you can see here, production keeps increasing until a certain point where it declines. The point where it begins to decline, that is a point when the marginal product of labor begins to become negative. So at the point where we employ 8 units of labor, we stop here, because if we employ extra units, we will now start going to negative. So the additional units that will be produced by additional laborer will be negative. So for you who are in human resource, generally you need to understand that there's a point at which you need to stop employing, more to which you will be spending more than you are getting from an additional laborer. Now, let me take you to the law of diminishing returns. So, the law of diminishing returns is really important because this principle helps us understand labor productivity. It helps us understand labor productivity that at a certain point you need to know when to stop employing. So, for the first isoquant, you are stopping at 6 laborers because more than 6 laborers it becomes negative. The isoquant 2 we stop at 7 laborers because more than that we go into negatives. Isoquant 3 we stop at 8 laborers because more than that we start going to negatives. Now let me take you into some arithmetic uh, relating to the formulas. I've said the total product of labor or the total product is denoted by letter Q. Anything divided by the labor units or the input units is called average. So Q over L, or the total product of labor over L, is called the average product of labor. Total product of capital divided by capital is called the average product of capital. If you're using calculus, if Q is written in terms of labor and capital, our dQ over the L is called the marginal product of labor. But the change in total product over the change in labor is called the marginal product of labor. If we are differentiating dQ over dk, this is called marginal product of capital. Now, I said the incremental changes in production is called marginal product. So the marginal product of labor times the price is called the marginal revenue product. This is in fact the value of the units that are produced by the individual in terms of money. The decision rule is always to stop employing when the marginal revenue product is less or equal to the marginal resource cost. So marginal revenue product must always be higher than the marginal resource cost. The marginal resource cost is the wage. So a hypothetical example I would give is this. You have 10 laborers who are working. These 10 laborers have an average product of, let's say, 1,000. And each unit of labor costs 2 kwacha. So we now want to understand what is our total product of labor. So we know that average product of labor is simply total product of labor divided by the labor units. Total product of labor divided by the labor units. So if you cross multiply, you're going to find that our total product of labor is simply the average product of labor times the number of laborers. So the average for the 10 laborers has been given in this case, that we have an average of how much? 1,000. For how many laborers? For 10. So how much are they producing in total? They're producing 10,000 units. So this is for all these 10 laborers. Now, if there's an additional worker who wants to join them, and this additional worker is bringing in, or is promising to bring in 12,000 units. He wants to bring 12,000 units. So what is our new total product? So the total product for 10 laborers is 10,000. So what is the total product for 11 laborers? Can somebody guess or compute? The total product for 11 laborers will be how many? 10,000 plus the addition that this guy is bringing. This new guy is bringing 12,000 units. So how much do we have in total for the 11 guys? 22,000. All right. Now, part C. If this new laborer is taken on, what is the average for the 11 laborers? So we know that average is simply the total product over the number of laborers. So our total product here is now 22,000. But how many laborers do we have? They were initially 10, but now they are 11. So our new average now becomes 2,000 instead of 1,000. Okay. Now, we are told that this additional worker, his wage that he was being paid was initially, the wage that was being paid was initially 25,000. And now the company is intending to dismiss this person. But before they dismiss this person, they want to do a cost benefit analysis. The question is, was he worth firing? Before we consider that, we need to calculate how much was the value he was contributing to this company. So to calculate the value, we call that value marginal revenue product. Marginal revenue product is simply the value of the additional units, which are called marginal product, times the price. So this guy brought how many units?